Hey everybody, this is Module 1, Lesson 2. We've got your essential questions right here. And today we're going to be talking about proportional relationships. So how can we tell if two quantities are proportional to each other? How can we recognize a proportional relationship when looking at a table or set of ratios? Of course, you know to pause this if you need to write these down. Okay, how many of you like frozen yogurt? I know I do. And if you paid attention, a lot of times the way that you can figure out the price is you set your frozen yogurt on the scale, and then the employee says, okay, yours is going to cost this much. Well, where does that come from? That's what we're going to figure out right now. We're going to figure out how much each ounce costs. So it says a new self-serve frozen yogurt store opened this summer, sells yogurt at a price based upon the total weight. So underline that phrase right there, based upon the total weight. That means that the weight determines the cost. In math, you're going to see the letters X and Y a lot, and that X is what determines the Y. So your weight determines the cost. So if you put on a container that's 12.5 ounces, the employee will tell you that costs $5. 10 ounces costs $4, so on and so forth. They are all the same price per ounce, so that's what we're going to figure out. We know that the cost is proportional to the weight, so this cost is proportional to the weight. Here's a question though. Do you notice that the cost, all these numbers, it's lower than the ounces, this number? Hopefully you can use reasonableness to know that means that each ounce is going to cost less than $1, because if it was $1 each, that would be 5 ounces would be $5, but it's not that much, it's less than that. So 5 ounces only cost $2. So hopefully you know that our answer is going to be a decimal less than 1. Okay, how can we figure out the cost per ounce? Think back to lesson 1 when we did the pencils, we found out the cost per pencil. So what we can do is we can do the cost divided by the ounces. And in any of those scenarios, 5 divided by 12.5, that one's got a decimal. I know sometimes decimals can look scary. You can also do 4 divided by 10. You can do 2 divided by 5. You can do $3.20 divided by 8. Okay, I'll give you a minute. You can pause it if you need time to type that in, and make sure you put it with a dollar sign. Okay, did you get 40 cents per ounce? That slash there means per ounce. Each one of those, when you do the cost divided by the ounces, you get 40 cents. Okay, what if I know the number of ounces? How can I determine the cost? If you know the number of ounces, whether it's 15 ounces, 20 ounces, no matter what, you can do the number of ounces times 0.4. Okay, let's go ahead and write that in another way where we can say cost is equal to 0.4 times the ounces. In math, in the future, you're going to see it like this, y equals 0.4 times x. Remember when I had you write x and y up here? The weight times 40 cents gives you y, the cost. So x is the weight, y is the cost. It's okay if this is a little too much for right now. I just want you to see the relationship that I take the ounces, if I times by 0.4, that tells me how much I pay for my frozen yogurt. So you can have different weights other than 12.5, 10, 5, and 8. So if it's 9 ounces, you would multiply by 0.4. If it's 15 ounces, multiply by 0.4. That's 40 cents. Okay, now, some of you out there might have divided the wrong way at first and said, oh, I want to do a big number divided by a small number. If you do 10 divided by 4, that's 2.5. That is not the price per ounce. In fact, what 2.5 means, That's how much you can get for $1. But the question said, how much is it per ounce? So we wanted to find out 40 cents, not 2.5. So for 2.5 means 2.5 ounces per $1. You usually see unit rates in money written as this way though, the price per ounce. Okay, moving on to example 2. Cooking cheat sheet. In a recipe book, it tells you that 1 cup is equal to 8 ounces and 2 cups is equal to 16 ounces. And then it also kind of helps you in between those, because then we know that sometimes you might need half a cup, and that's equivalent to 4 ounces. Sometimes maybe your dishes are dirty and you have a container that tells you ounces but not cups. Sometimes you're doubling a recipe or cutting it in half. Sometimes you might have the cup and not the ounces. So it just depends on your situation, but this is a good little tool that it provides in the cookbook for you to say 1 cup is 8 ounces, 2 cups are 16 ounces, and that's proportional. The ounces are proportional to the cups. What do I multiply the cups by to get the ounces? In other words, how did I get from 1 to 8? How did I get from 2 to 16? I'm using those because they're whole numbers. It's the same relationship as 1 1/2, 12, or 1/2 to 4. It's cups times 8 equals ounces. Don't believe me? Type this in your calculator. 1 1/2 times 8, you should get 12. 1/2 times 8 should give you 4. So go ahead and try that and see if it works. Okay, on to page 7. Let's talk about this exercise. Jose's physical education class today, students visited activity stations. Next to each station was a chart that said how many calories would be burned by completing the activity. All right, so it says however long you take jumping rope, 0, 1, 2, 3, 4 minutes, however long, it converts that and tells you how many calories you've burned. You could talk to your parents. There's a chance that maybe you know somebody who works out, and on a treadmill, it'll say, okay, you ran for this many miles, that means you burned this many calories. So this is something similar to that. So is the number of calories burned proportional to time? And how do you know? So is the number of calories burned proportional to time? How do you know? Well, what do you think right now in your head? Think, yes or no? Is 1 to 11, 2 to 22, are those proportional? In other words, am I multiplying it by the same number every time? Hopefully you're good with your 11 facts, and yes, you are always multiplying by 11. Keep in mind, if you don't jump rope, you don't burn calories, but it's actually still consistent with what I just said. 0 times 11 is 0. Okay, what about 6 1/2? Do I have to keep going? Do I have to say, okay, here's 5, here's 6, here's 7, 55, 66, 77. Do I have to keep the chart going in order to figure out 6 1/2? You could do that and then figure out what's between 66 and 77 calories, or you can just do what I said here. If you multiply by 11, just do 6 1/2 times 11. And you would expect to burn 71.5 calories. And there's the math right there. 6 1/2 minutes times 11. And that gives you 71.5 calories. Okay, of course you can pause it if you need to catch up. Don't ever go faster than you're able to write this down and process it. Okay, for example 3, and actually this is the last one before our summary. We've got a summer job. So it says that Alex spent the summer helping out at his family's business. He was hoping to earn enough money to buy a $220 gaming system by the end of the summer. Halfway through, after working for 4 weeks, he earned $112. He says, if I continue to work and earn money at this rate, so underline that right there, at this rate. And you can always be underlining anything that catches your eye or you feel like is important. Will I have enough money to buy the gaming system by the end of the summer? To check his assumption, he decided to make a table. He entered in his total money entered at the end of week 1, earned at the end of week 1, and his total money earned at the end of week 4. Okay, so what I want to do is go ahead and fill in, if he works 0 weeks, how much does he earn? $0. What about, sorry, let me move something here. What about if he works 1 week? They told us that was $28. What about 2 weeks? If 1 week is $28, go ahead right now, pause this, fill in what you think 2 weeks would be. 56. Okay, now pause it and see if you can fill in the rest of them. If you know what 1 week is, you should be able to fill out all the other weeks. And it should stay consistent with 4 weeks being $112 because that one was given to you. Okay, pause it and then unpause it to see the answers. How did you do? Circle any of these that you got wrong or you're not quite sure where the number came from. Are his total earnings proportional to the number of weeks? Yes, because the unit rate is 28. And for an extension, I'm showing you this graph again, where Y is your total earnings and X is the number of weeks. So all you do is you take 28 times the number of weeks, and that will give you the total earnings so far. Okay, and then 8 weeks, he's got $224. So he got enough to buy the gaming system. Okay, the last thing that you need to do is just write down your summary. So measures are proportional if the second quantity, there's a positive number k, so that for every measure x, the corresponding value y is given by kx. That might sound really confusing, and all that means is you multiply by the same number every time. So think back to Alex's example. 1 times 28, that was $28. 2 times 28, $56. 3 times 28, 4 times 28. You're multiplying by the same number every time. So you can even write that in there if that helps it make more sense. Okay, and then even if this looks confusing, you are going to be professionals at using this formula, y equals kx, in the very near future. So don't just skip over it. Okay, sorry about that, Fox. Okay, so just pause it as long as you need to, and make sure you get your summary copy down, and we'll work on the independent practice